Hey boys and girls, so today we're going over Unit 7, Lesson 6, which is Analyzing Quadratics. Before we jump in, just make sure your name is written down at the top, and let's look at the do now. It says a water balloon is thrown from the top of a building at 48 feet. The path of the water balloon is shown on the graph below, where y is the height in feet and x is the time in seconds. Answer the following questions based on the path of the water balloon. So before I actually read the question, I want to make sure that I'm identifying all my key information that I just read in that first chunk of the question. So it says that a water balloon was thrown from a height of 48 feet. It also tells me that y is going to be the height in feet, and it also tells me that x is going to be the time in seconds. Now, I've already labeled my graph where the x-axis represents time in seconds, and that comes right from the question. And I know that y represents the height in feet, so again, I labeled that as well. So you guys should be adding this to your notes. All right, and then again, if I know that the water balloon is thrown from the building at 48 feet, well, that makes sense that I can see that my graph here is starting at 48 feet in the air, because here I am, boom, 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 big smile, right? I'm holding my water balloon, and I'm about to launch it into the air, up, 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 and eventually it falls on the ground. All right, so when I look at the question, it says, what is the height of the water balloon after 4 seconds? Explain your answer. So as I'm looking at this question and it says, what is the height? Because we always want to answer our question by underlining it here. So if it says, what is the height? I know that height would be a y value, so I'm just going to write that up top here. I should only be looking at the y-axis to answer this question. All right, so if it says, what is the height after 4 seconds? Well, let me just highlight that out for us. At 4 seconds, which is right here, I'm going to go right up to my graph, all right, and I want to see what height is that going to be. And I can see that it's going to be 112 feet. So if I want to answer this question completely, all right, what is the height? I'm going to say it's 112 feet. But it says explain, underline that, explain your answer. Well, there's 2 different ways that I could explain my answer. I could write down that at 4 seconds, the water balloon, right, the balloon was 112 feet. All right, so that's answering the question using the context of the problem, because the problem was talking about a water balloon, so I'm including that in my answer here. I also could have said that when x equals 4, because I know that my x-axis represents my time in seconds, so I'm really saying that when I was at 4 seconds, my y value, which was my height in feet, my y value was 112. All right, so there's 2 different ways I could have answered this question. This would have been one when it comes to explaining. This would have been another when it comes to explaining. All right, this is what we're going to be working on today, evaluating graphs. All right, so at the bottom here, it says analyzing quadratic graphs. Using the same graph from the do now, we want to answer the following questions. So I'm going to use the same strategy we just went over in the do now. As I read part A, it says at what time. We always want to underline the question. If it says at what time, I know that time is on the x-axis, so I'm going to just put an x here to remind myself that I should only be using an x value when answering this question. All right, I'm going to do the same thing for B, C, and D to just get a head start here. So part B, again, it says at what time. Time is on the x-axis, so I know I want to use an x value. Part B, it says how much distance. Well, distance would be feet, inches, all right, and I can see that my height here is in feet. So at what distance? Distance would be a y value. All right, and then part D, it says at what height? Again, height would be a y value. I know that my height is being represented in feet. All right, so that's where I want to look when I answer part D. All right, so let's jump back up to part A to get this done. It says, at what time does the water balloon reach the ground? Well, if I look at the path of my water balloon, I can see here, let's highlight that out. This is where it starts because I'm holding it, it's in the air. I'm launching it into the air, boom, 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 and eventually, ooh, falls right on the ground. Falls on the ground right over here on my x-axis. So I just want to now ask myself, what x value is this going to be? Because part A says, at what time? Time is an x value. So what's the x value of this point? Well, I can see it's right in between 5 and 6. So what number is in between 5 and 6? It's going to be 5.5. Excellent. All right, so at what time? I'm going to say at 5.5 seconds. because I know my time here is being represented in seconds. Part B, it says, at what time does the water balloon reach its maximum height? So that's going to be its highest height on the graph here. So as I look back, I can see again, here's the water balloon, it's in my hand, I launch it into the air, boom, 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 boom. All right, and then it goes all the way up to this value. That's going to be my maximum. All right, but again, the question says at what time? Time is an x value. So I want to drop this down and look at what x value is this maximum point being represented by. And again, I'm in between 2 and 3. What number is in between 2 and 3? That's going to be 2.5. So part B, at what time? It would have been 2.5 seconds, or 2.5 seconds. Part C, it says, how much distance does the water balloon travel from 1 to 2 seconds? So this might be a little bit tricky. So let's look at this part with a different color highlighter here. Let me do a blue one this time. So if it says between 1 and 2 seconds, well, here's 1 second. Here's 2 seconds. I want to look at the path of that water balloon from 1 to 2 seconds. So I'm only looking at that blue chunk that I just highlighted out here. And if it says at how much distance was traveled, we know distance is y values. So again, I'm just going to carry this right over to my y-axis. All right, so I can see that at 1 second, the balloon was 112 feet in the air. And at 2 seconds, the balloon was 144 feet in the air. So how much distance was traveled? Well, I can easily get that answer by taking 144 and subtracting it from 112. All right, I want to see how am I going to get from this number to this number up here, and I can do that using subtraction. So when you type this into the calculator, you end up getting 32, but it says how much distance. I'm going to say it was 32 feet that was traveled. All right, and then part D, again, it says at what height? Height is a y value. So at what height does the water balloon reach after 4 seconds? Well, I can see, again, just looking at my graph, this is how high it was after 1 second. This is how high I was after 2 seconds. This would have been after 3 seconds. I want to see at 4 seconds. So I'm just going to go back, and I'm going to highlight that out. All right, but I can see that at 4 seconds, we already highlighted that before. That was actually from the do now. So at 4 seconds, what was the height? What was that y value? It was a y value of 112. All right, so it says at what height does the water balloon reach after 4 seconds? We're going to say it reaches 112 feet. All right. All right, here we go. Example 1. It says an angry bird was fired into the air with a giant slingshot. The path of the angry bird is modeled below. At what height was the angry bird launched from? All right, so I'm following the same strategy that we just went over on the first page. As I'm reading the question, I'm underlining it, but I'm also looking for the key word that tells me what axis I should be looking at for my final answer. So I can see here that my x-axis, okay, represents time in seconds, and my y-axis represents height in feet. So when it asks what height, I know height is a y value. That's why I'm circling it, and again, using that value over here. So at what height was the angry bird launched from? Well, let's find him. Let's highlight him out. So I can see my angry bird is right over here. So when it says at what height, which is a y value, I want to look right over here at my y-axis, okay? And I have to determine what that value is going to be. All right, so what number is right in between 10 and 20? You got it, it's going to be 15. So I'm going to say this is a height of 15. So for part A, when it says at what height was he launched from, I'm going to say it was 15 feet because my height here is measured in feet. Now, if I look at my y-axis, okay, I know that I'm counting by 5s. That's going to be the scale that I'm using because at the bottom of the ground, right, that would be 0 feet. What number is in between 0 and 10? 5, right? So this would be 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, right? So on and so forth. I could go all the way up. So just be aware of that. And that's going to be the scale I'm using for my y-axis. Part B says, what is the maximum height of the angry bird? Again, height is a y value. All right, so I know I want to look at my y-axis for that answer. If it says, what's the maximum height? Well, here we go. Here's my angry bird. He gets launched, thrown into the air, and this is going to be his highest point right around here before he starts turning and then falling onto the ground. All right, so if it says what's the maximum height, again, height is going to be a y value. So I'm going to just draw an arrow right over here to my y-axis, and I can clearly see I'm hitting the number 50. So what's his maximum height? It's going to be 50 feet. Part C, at what time? At what time does the Angry Bird reach the ground? Well, here he is. He's in a slingshot. Whoop! He gets launched into the air, and then eventually he falls to the ground, which is right over here. But it says at what time? Time is an x value. So when I look at my x-axis, I can see I'm hitting the value 8. So I know he reaches the ground after 8 seconds. Part D, it says, what is the height? Again, height is a y value. So at what height does the Angry Bird reach after 6.5 seconds? Now, when I look at my x-axis, because 6.5 seconds would be an x value, I don't see 6.5 anywhere. So I'm gonna have to figure out what I'm counting by. What's my scale for my x-axis? Well, again, I'm starting at 0 seconds. What number is in between 0 and 1? Nice, it's gonna be 0.5. So this would be 0.51. Then it would be 1.52, 2.53, and I'm just gonna continue this pattern all the way down. So I have 3.54, 4.55, 5.56, 6.57, 7.5, and 8. All right, so now that it's all filled in, I can go back and try to answer the question. So at 6.5 seconds, what's the height gonna be? I'm gonna grab a highlighter for that. So here is 6.5 seconds, and I wanna see where on my graph that would be. All right, I can see it's gonna be that point right there on my parabola. And now I wanna check with an arrow over, to my to my y value, what height is the Angry Bird at when it's at 6.5 seconds? Well, when I come over to my y values, I can see it's 35. So at 35 feet, all right, that would have been 6.5 seconds. All right, last but not least, E and F. E and F are very similar because they both say over what interval is the height of the Angry Bird. Part E says increasing and part F says decreasing. All right, so if I want to see where he's increasing, let me go back up top to the graph. I'm going to just highlight that out. Here's my Angry Bird. He is in his little slingshot here, right? And then he's getting launched all the way up into the air until he hits that maximum value, the maximum value that we already circled before. I'm going to put an I here to represent increasing. That is where he is going up into the air. Once he hits that maximum value, he is then going to start decreasing until he finally hits the ground, all right, which is over here. I'm going to put the letter D to represent decreasing. So when I look at my answer here for E and F, it says over what interval is he always increasing? Well, when you see increasing or decreasing, you only want to look at the x values for these, okay? That's something that just needs to be memorized. So on my graph, I can see the first x value. Let me draw an arrow down here with my blue, all right? My first x value, I can see that I'm hitting is 0. And then again, all the way up to that maximum height, I can see the next x value I'm hitting is 3.5. So when it asks over what interval is the bird always increasing, I'm going to say from 0 to 3.5. This is interval notation, okay? I have my lowest value, comma, my highest, and now I have to decide if these are going to get parentheses or brackets. Boys and girls, it's always going to be parentheses, okay? These values are never included because at 0 seconds, he is in the air, 3.5 seconds, right, he's in the air. I'm not going to put brackets around those points. I am always going to use parentheses instead. All right, so that's where he's always increasing. Now I want to look at where he's always decreasing. Well, it turns out that he's starting to decrease at 3.5 seconds as well. All right, that's okay. They can overlap. So he's going to start to decrease. He's going to start to become orange at 3.5 seconds, and then he's orange all the way until he hits that value of 8. Again, I'm only looking at my x values here. So from 3.5 to 8, that's going to be where he is decreasing. Again, I'm writing this in interval notation. And again, I'm going to put parentheses around that interval because anytime I am increasing or decreasing, you always use parentheses to represent that. All right, so again, this was example 1. I'll meet you on the next page for example 2.
All right, example 2, it says a baseball pitcher is throwing the ball to third base in an attempt to get a player on the other team to be out. The path of the baseball is shown below. So I just went ahead, and again, I had marked with a y, okay, this variable here because this is the y-axis. I put an x over here because I know this is the x-axis. And then I read each question and I identified what the key word is going to be to answer these questions completely. So in part A, it says from what height is the baseball thrown? Height is the y-axis. So I put the letter y to remind myself I need to use one of these numbers in order to answer this question. So if it says from what height is the baseball thrown, well, I can see here's my pitcher, and he's throwing the ball right at this value on my y-axis here, but I don't know what that number is. I need to figure it out. So if this is a height, I know that at the bottom, that would be the ground. That would be 0 feet, all right? Now I have to think, well, how do I get from 0 to 5? I have a ton of boxes in between, so let me try to count by ones and see if that works. So this would be 0, 1, 2, 3, 4, 5, and I can see that it will, so let me number that out. 0, 1, 2, 3, 4, 5. I'm going to go a little bit more. We have 6, 7, 8. So it looks like at 8 feet, that's where the baseball is being thrown. But I'm just going to go a little bit more to finish off this scale. All right, so that would be 8, 9, 10. And let me go just a little bit more. We have 11, 12, 13, 14, and then 15. All right, this is the highest point on my graph. That's going to be my maximum. So I don't think I'm going to need any of these other values, so I can leave them out. So again, for part A, if it says from what height is the baseball thrown, I'm going to say a height of 8 feet. All right, fill that in with me. Part B, it says at what time does the baseball reach its maximum height? Well, again, here's the pitcher. He's launching the baseball into the air. Boom, 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 boom. Right here, I can see that this value is going to be his maximum height. That's the highest point on the graph. But it says at what time, so I know I want to use an x value to answer this. So when I drop a line straight down to my x-axis, oh, that number isn't there. But that's okay, I can figure it out. So we know that our y values have a scale of 1. That means I'm counting by 1 each time to get to the next box. Now I need to figure out what the scale is going to be for my x-axis. All right, I can see there's a lot of boxes in between 0 and 1 here. So if I count them, I can see there's 1, 2, 3, 4 boxes, okay, in between 0 and 1. Well, just thinking of real life, I know that 4 quarters get me $1. I'm going to try to count by 0.25 each time, and I'm going to see if that works. So we have 0.25. Then we have 0.50. Then we have 0.75. All right, then we have $1. So it looks like that's going to work. I want to keep up with that scale. So then we have 1. Then we have 1.25. Then we would have 1.50. Then we would have 1.75. Then we have 2. And I'm going to keep that scale up. Then I have 2.25, 2.50, 2.75, $3. All right, so I can continue that all the way through. I'm going to put it on pause just for right now, because right now I want to answer part B. It says at what time. When I drop this down, now I can clearly see the time is going to be 2.5, so it would be 2.5 seconds. All right, 2.5 seconds. All right, let's look at part C. It says, what is the maximum height of the baseball? Again, height is a y value, so I want to look at my y-axis to answer this. I'm going to use a highlighter for this section, okay? So let me grab my pink highlighter here. So if it says, what's the maximum height? Well, this was the maximum point. So if I want to know the maximum height, which is a y value, I'm going to draw an arrow right over to my y-axis, and I can see I'm hitting the value of 13. So what is the maximum height? It's going to be 13 feet. All right, part D, it says after how many seconds does the baseball reach the ground? Well, it's in the pitcher's hand. It was launched into the air. Eventually it falls onto the ground. I can see over here it is at the ground. What x value is that going to be? It's an x value of 6. So I'm going to say it was 6 seconds. All right, now we got E. E is a little bit tricky. It says how much distance is feet, so that would be a y value. All right, so how much distance does the ball travel between 1 second and 4.25 seconds. All right, so I'm going to grab a highlighter here to highlight this out so I can clearly see what's going on. So at 1 second, all right, this is going to be the height of that baseball. I can see it's 12 feet in the air at 1 second. But I also want to check at what height was the baseball after 4.25 seconds. Well, if I look at my scale, I don't really have 4.25 written down just yet, but that's okay. I can easily add it on. We just said before that my scale counts by 0.25. So if this is 4, next would be 4.25. All right, so from the first line after 4, I'm again going to highlight up to my graph, okay, which is going to be this point right here. And then again, I want to arrow it over to my y-axis, because if it says how much distance, I want to see how many feet were traveled. Well, how do I get from 11 feet to 12 feet? Well, that's 1 foot. All right, if this was a bigger set of numbers and it wasn't as easy to see, well, how do I get from 11 to 12? Or you add 1, so that's 1 foot. You would just subtract those numbers. So let's write that down. I would take 12 feet, which was my bigger number, subtract it from 11, that was my smaller number, and I get 1 foot. So I know that 1 foot was traveled. That's the distance between these 2 time intervals. All right, so just be aware of that. And then part F, it says, over what interval is the baseball always decreasing? Well, we just went over before that this value up top represents my maximum point. All right, so here's the picture. He's throwing the ball into the air. This whole first half of my parabola would represent where the ball is increasing. It's going up. From this point all the way down, when I'm highlighting out in orange, that would represent where the ball is now decreasing. So if I want to write the interval of where it's decreasing, I want to look at those x values. So when I drop my line down to the x-axis, when I drop my line down to the x-axis, I can see the values that I'm hitting are 2.5 and 6. So that's going to be the values I want to pick here, 2.5, comma 6. Again, I'm writing this in interval notation, and we know that interval notation always goes in parentheses. Okay, that's something that just needs to be memorized here. All right, that would be example 2. I want you guys to right now pause the video, and I want you to do example 3 on your own. Okay, once you're complete, then you can check back to see what that final answer was going to be. All right, boys and girls, here we go. Example 3, it says the graph below shows h, the height in meters of a model rocket, versus t, the time in seconds after the rocket is launched. All right, so we had to answer all of these questions. Here are the answers, okay? Something that I noticed was that my x-axis, my time in seconds, wasn't labeled for me, so I did that myself. Okay, so again, t is the time in seconds. I saw the variable t, so I knew this was going to be time in seconds. H is my height in meters. Here was h, so I knew this was my height in meters. Okay, so right off the bat, you should have labeled your x and y axis. Something else you should have noticed was the scale that the x values and the y values are counting by. My x values are counting by a scale of 0.25, just like they were in the last example. So I have 0.25, 0.5, 0.751, and it continues all the way through. I can see my y-axis has a scale of 1. Okay, so I'm counting by ones. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right, so on and so forth. So here are my answers based on my graph for parts A, B, C, and D. All right, as I scroll up here, these are going to be the answers for E, F, and G. Part E, again, it says increasing. You are only looking at the x values. You always use parentheses. And then F and G, I circled these in green just so when you guys are checking your work, you can see where I got those values from. So in green on the graph, this is where I highlighted out, and then again in green on the graph, this is where I highlighted out, just so you can see where those values came from. All right, please make sure you guys get this done. I'm going to just zoom in one time here, just so you can get a really clear look at my graph to make sure yours looks the same. All right, feel free to pause the video if you need to. Now I'm just going to flip to the last page here. which is going to be your closure and the homework. Make sure you guys are answering the closure completely. And then the same thing with the homework. Make sure you guys are answering all 3 questions completely before you submit this on Canvas. Awesome. Have a great day.